Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at verifying connectivity. We'll be discussing verifying connectivity with ping and extending ping. We'll look at verifying connectivity with traceroute and extended traceroute, and then we'll end with a discussion on network baselines. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. One of the easiest ways to verify your layer 3 connectivity, your IP addressing routing, is to use the ping command. The ping command actually does two steps in the process. First one is it sends out an echo or an echo request that goes from the source computer to the destination. The destination hears that echo request, processes that, and then sends back an echo reply. Here in the example, as you can see, we are pinging 10.1.1.10. PCA, that's not that PC. PCA is on a different, completely network, 192.168.10.10. We are pinging a 10.1.1 computer. And so that ping, it sends out an echo request. It goes through our local area network, goes out our edge router, goes across the internet. Whatever the ISP does to route it to its final destination, makes it to the edge router for the destination network, and finally it gets to the PCB, the 10.1.1.10 computer. It takes the echo request in at that point in time, processes that, and then sends back an echo reply. That echo reply comes back from PCB, and notice how the source and destination have now changed. We are sending out a new protocol data unit, and the source and destination have switched because now the roles have switched, because we are sending, instead of that echo request, we're sending that echo reply. The source and destination IP addresses, those have changed. And so it goes from our PCB on the right side all the way through their network, through the internet, back to the computer that originally made that request. They get that in there, and what that does is it verifies you have layer 3 connectivity all the way from the source to the destination of that ping and back again. It says IP addressing is set up correctly, you have IP routing that's configured correctly, your ISP is doing everything on the internet correctly. Easiest way to verify your layer 3 IP addressing. Different operating systems use ping a little bit differently. In particular, Windows and Cisco iOS, they implement ping a little bit differently. Windows sends out 4 consecutive echo requests, and they expect 4 echo replies coming back in. Windows sets out 4 sets of those echo requests and expects 4 echo replies, and that's how Windows decided to implement the ping command. Cisco iOS, on the other hand, they do 5 sets, 5 echo requests. They expect 5 echo replies back in. Just how they decided to implement it. Now, the Cisco iOS, they give you some information as you look at this. When you do a ping in the Cisco iOS, you typically get back 3 different types of markers for those 5 sets of echo requests and replies. The first one here is an exclamation mark. That exclamation mark means it worked good. Thumbs up, we're happy, we sent out an echo request, we got a reply back, we got 1 exclamation mark. We sent out a second one, we got the reply back. That gives us 2. If you get 5 exclamation marks, you're doing a good job. A period means it timed out. We sent out that echo request, we sat there, we got nothing back. And so what that period means is it just never came back. It was a timeout. The third one here is an uppercase U. And that means the destination is unreachable. Somewhere, a device on the path that you're pinging to, so you ping from your PC to your router through the internet of your ISP to that far PC, somewhere along the line, they got that echo request in, that device said, hey, this is as far as it's going to get, and we can't reach our destination, so we're going to send an unreachable reply back. That's what the U is saying it's unreachable. We got part way there, but we didn't get all the way there. On a Cisco device, we can do what we typically refer to as an extended ping. What we do here is we are in privilege exec mode, and you type in ping, but then you don't type anything after that. You go ahead and hit ping. It's going to give you a series of questions. These questions will allow you to customize that ping to exactly what you want. As you go through these questions, if the question has an answer in the square brackets and you want that answer, all you have to do is press enter at that point in time, and it's going to use what's in the brackets. And as we work through here, so the first one is, yes, we wanted to use IP. The second one here, target IP address. You go ahead, you type that in. And so that's our target. What's the repeat count? If you want to send just one or you want to send 100, go ahead and change that. How big is that piece of data we're going to send with the echo request, with our echo reply? How long is the timeout? Maybe you know that there's a lot of congestion on your network. That 2-second timeout is not long enough. Maybe you want 5 seconds. Coming down here. And then this is where the fun part is. What is the source address or interface? Now, in this example, this is the device we're actually pinging from. What you can do is you can put in a different computer or a different device is IP address in here. This is oftentimes referred to as the ping of death. And what happens is it sends out an echo request to that target IP address from up here, but then that echo reply goes not back to this device you're on, but it goes to that IP address you're using here. And this could be your friend's computer. This could be a competitor's computer. This could be a computer or a service on the internet somewhere. And what they do is they get this echo reply in. This echo reply comes in. They never sent out an echo request. And at this point, the device can get confused and it can get overloaded. Typically, you have firewalls set up to block this. But if you find a system that doesn't have any mitigation features on that, you can start to confuse it and overload its buffers and really confuse that. You can go through, fill out the rest of the data here. Finally, getting down to the end, it sends it out. And if you're successful, once again, we get our 5 exclamation marks at the end. This is for IP version 4. If you want to do IP version 6, the command here is ping, and then you put IPv6 in there with no address in there, and then you can go through and enter in those commands also. I hope you're liking this episode on verifying connectivity. If you have the time, please leave a comment and let me know what you think about verifying connectivity. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Using ping, you can quickly identify if there's a layer 3 configuration issue between the source and the destination, but it doesn't tell you where that problem lies. Now, if you want to know where that problem lies, you can use what we call the Traceroute command. Normally what I do is I go and use ping for my source and destination. If it works, then I carry on. But if it doesn't work, I follow it up using a traceroute command. Windows and Cisco, they've implemented traceroute a little bit differently. On a Windows system, the command to use traceroute is Traceroute, T-R-A-C-E-R-T. They've abbreviated it. On the Cisco iOS, it's the word traceroute. All one word, no spaces. Why did they choose to implement it using different keywords? That's just how they did that. But they function the same. They go through and they connect each network interface along the journey to the final destination. When you do traceroute from a Windows box, and remember, it is Traceroute, T-R-A-C-E-R-T. You put the IP address in of the destination, and it works through all of the hops. It works through all the network interfaces. And a good step in the process, you can have up to 30 steps or hops. A successful one here comes back and it says, okay, this is the first hop, number one in the first left column. Then the next 3 columns typically have milliseconds in here. That's how long did it take the message to go to that first hop and come back. And then we have the IP address. A successful one will have all of these fields propagated. It'll have times in the 3 middle columns. It'll have the IP address. That's successful. Then an unsuccessful will get these asterisks for times, basically saying it timed out, it timed out, it timed out. And the message, instead of an IP address here, is going to say request timed out. We didn't reach the destination. And so what we can tell you here is the last successful one, the one with the 3 times with the IP address, this is the last successful one. You go back, you look at your topology and say, okay, I can make it up to this device, and then the problem is right after this device somewhere. It's either the connection between that last successful device and the next device, or maybe it's the next device, but at least you've narrowed it down to an area of your network. Here we can look at the Cisco iOS version of Traceroute. Once again, the command here is Traceroute, all one word, no spaces. Traceroute, all one word, no spaces. Then you put your IP address in here. A successful Traceroute here shows you each IP address, each hop. And so this is the first hop here. This was the IP address it was checking. This is the response time in milliseconds. That was successful. 2 was successful. Once again, another hop, another network interface in our journey. That was successful. Then we have the third one. That was another IP address with times here. That was successful. We don't have anything timed out. They were all successful. That was a successful traceroute. An unsuccessful one, coming down here, you can look at this next one. The first hop here, the first ping in this traceroute, we successfully got to an IP address. We have our times, so that worked. The second one was successful. Once again, we have another IP address. We have some times in here. But then the third one was not successful. We have asterisks in there. Asterisks, once again, says this is timed out. We did not hear any responses back from our destination. We can't do that. And this also leads us to the last successful one. We know we can get traffic up to this point. The problem is probably with the far side of that device or that connection or the next device. We've narrowed it down to a portion of our network where that problem is. That helps us do more efficient troubleshooting. Just like an extended ping, we can do an extended trace route. We can modify different options, allow us to do more hops, to have a longer timeout. In Windows, what you can do is you can enter in Traceroute. Once again, no spaces in there, Tracert, space, and then a / and a question mark, and then it gives you all the options you can do for our extended one. In the Cisco iOS, you can enter in Traceroute again. Here's an example of Traceroute, and you don't put an IP address in there. Don't put an IP address, and then you can go into all of the options here. We have the source, we have the target, we have what the timeout is, how many probes are we sending. By default, it's 3. Maybe you want to send 5 or 10 just to really make sure you test those different hops in the journey. And it goes through and it processes that. And then finally at the bottom here, it goes and it does the trace route and it gives you the results. One of the best tools in your arsenal as a network administrator is baselines. What a baseline is it's used for monitoring and troubleshooting network performance. It gives you a snapshot of what your network is. And to start out, if you're on a small network, what you do is you go through and you copy and paste results from the simple network tools you have. You use ping, use trace routes, use other other commands there. You copy those results, put them into a text file. That way you can save it and you can look back and compare your results over time. And all of a sudden, if one day your network is really slow, you can go back and say, okay, normally these are our response times. This was a successful trace route. This is our normal response times. This is what it should be. You do a trace route now and you can see, hey, this hop here, the 5th hop in our journey, is giving us a really high response time. It has a lot of latency built into it. This is where the problem is, and now you can start narrowing down where that problem is. One of the other big things to look at is your error messages. What are the error messages actually saying? Open up those log files, look at them and see what those error messages are saying. If they're saying that they can't reach the destination, then you do a trace route to that destination and figure out what the problem is. These error messages a lot of times give you some great insight on what the problem is on your network. The more you use baselines, the more you're going to see these tools are what you're going to use quite a bit for your network to troubleshoot and also to help you make decisions on, do we need to improve, update, upgrade our network components? There are tools built into operating systems. Windows has performance monitors and a couple other tools like that, but there's a whole list of other professional grade tools out there. Some of them are open source, some of them are paid, but these tools automatically look at baselines, automatically track trends, and they help you analyze all of this. The problem with baselines is they're always secondary to a lot of the other job functions you have to do as the network administrator. Your network connection is down, your internet connection is down, you have a router that is giving you errors. Those problems need to get taken care of right away. Collecting that baseline data is something that a lot of times doesn't get done because there was other things to do. But when you go back and you need that data, it's not there. And so what I do is I typically pick out a day or two a month and say, this is what I'm doing. I'm creating baselines there. I put it on my calendar and say, the first Monday and Wednesday of every month, I'm going to collect data. And actually, I don't do the first week, because the first week usually has other tasks associated with it. I usually look at like the second or third week. The second Monday, the second Wednesday of every month, that's when I'm going to collect my data. That'll allow me to get my data. If I do that every month over the course of the year, I'm going to have 12 baseline snapshots and I can see trends. It was my pleasure to provide you with this wonderful episode on verifying connectivity. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.